Woohoo! So our aim for today, how did the scientific revolution challenge the medieval view of the world? Understand when I'm saying the medieval view, we talked about the Middle Ages sort of in various places in the world. We talked about it with the Islamic empires, African kingdoms, Japan, China, Korea. We also talked about it in Western Europe. And right now, with the scientific revolution, much like the Renaissance, the focus here is on Western Europe again. And really, up until this point in the West, it's going to be the Greek views of nature that are going to dominate what they call science for about 2,000 years preceding this. And so really we're looking at the Ptolemaic geocentric model of the universe, that the planets, sun, and moon revolve around the Earth in a circular motion, because that's what people thought that they were observing by looking at it. Theories of like the four humors for medical treatment, like keeping those fluids in your body, black bile, yellow bile, phlegm, and blood all in balance. The medieval doctors believed that for a person to stay healthy, they needed to keep a balance among all of the humors. And anything that seemed unexplainable was decided or defined by the leaders of the Catholic Church. And what the scientists are going to find during the scientific revolution is that even things that can be explained through science and become explainable through science will not necessarily be accepted by the political establishments or the Catholic Church at the time. So what led up to the scientific revolution? Well, number one, the influence of trade with Islamic empires. Remember, the Crusades are going to bring these different groups of people, this disparate group of peoples, into contact with each other. And they're going to realize, while they have not had very many advancements at all in Western Europe, other places have continued to thrive. So it'll really be the Islamic empires that reintroduce them to the works of Greek and Roman scholars. It will be the Islamic empires that introduce them to some of the mathematical techniques that they drew upon and some of the inventions and discoveries from China. And next we have the influence of the Renaissance. So this focus on humanism, realism, symmetry, geometry, this is going to inspire scientists to delve deeper into astronomy and anatomy. We're focusing less on the church, less on the afterlife, more on the here and now and understanding the world that we live in. And lastly, the influence of the Reformation. So this rejection of traditional doctrine of the Catholic Church. It's going to inspire scientists to question these long-held beliefs and views and search for scientific evidence to prove them, not just faith alone. And certainly not just the teachings of a church who isn't even speaking to them in the language that they understand. And you do want to note that although we have things like the Renaissance at this time and the scientific revolution, these big changes, it doesn't mean it's changing the daily lives for everybody. It's just eventually it will. This is where these ideas start to take hold. So I want to talk about some of the people. So who discovered what and was it accepted? So a little gossip about each person to help you hopefully remember them. So first up we have Copernicus, and Copernicus is going to be credited with the heliocentric model, though to be fair, he wasn't the first person to come up with it. As far as interesting facts about Copernicus, one would be that he went to 3 different universities but never earned a bachelor's degree. And another interesting thing about Copernicus actually involves his heliocentric model, which I will explain on the next page. So this geocentric versus heliocentric model of the universe, here for the Ptolemaic model of the universe, where you have the Earth at the center and the celestial bodies moving around the Earth, that would be the geocentric model. And the heliocentric model has the sun at the center and everything, including the Earth, revolving around the sun, at least in terms of planets. The moon would be obviously orbiting the Earth. But what's fascinating about this is Copernican model, where we put the sun at the center of the universe and call it a heliocentric model. Copernicus didn't actually put the sun at the center of his heliocentric model. He put it near the center of his heliocentric model. And the question of whether or not his ideas were accepted or rejected, well, ultimately rejected. It was too early But to be fair, though, Copernicus didn't really experience a lot of that rejection in his own life because he did submit his research to other scholars of the day. And some of them said, no, this goes against the teachings of the Bible. And others were okay with it and even encouraged him to continue his study. He ultimately published his work and died soon after, so he didn't get to experience the rejection that would come with Galileo when Galileo approached his heliocentric model. Okay, now this guy here, he's one of my favorites to talk about, actually. I'll start with the fact that I can't pronounce his name. I'm not sure if it's Tycho or Tycho. I'm not sure anybody's sure. And his last name, I don't know if it's Bray or Brahe. I don't know. Anyway, I'll probably go back and forth between calling him Tycho and Tycho, but you'll know who I'm talking about. To start, though, he's an interesting childhood. So Tycho was kidnapped, sort of, as a 2-year-old. He was taken by an uncle. I mean, the deal was this, that Tycho's parents had promised to give this very wealthy uncle their child, and when they had their child, they changed their mind. And when Tycho was 2, his parents had another child, so Uncle Jorgen figures that, you know what, nobody's going to miss Tycho now, they've got another kid, and so they went and took him. And the parents, without the parents' consent, and the parents didn't contest it at all. As a result of being taken care of by this uncle, though, he grew up with a certain amount of wealth. And that does explain how he was able to do what he was able to do, scientifically speaking, because he had the time, the financial resources to make stuff happen. He did so many other interesting things, like he kept an elk for a pet. People think it might have been a moose, I'm not really sure, but Tycho refers to it as an elk. He got into an argument at his university with another student over who was the better mathematician, and they decided to solve the dispute by having a sword fight. So no math competition, no, just take it to a duel. And in this duel, Tycho lost, and he lost more than his honor of being the best mathematician. He also lost his nose. And you have to think about the time period and what cosmetic surgery would have looked like. He had a replacement nose made out of brass. And actually, for a long time, people thought that it was made out of gold and silver, but it was actually brass. They discovered it in 2010 when his body was exhumed. And I'll explain why that happened, too. But no problem about the nose. Tycho kept, a little extra glue on hand just in case his nose suddenly came loose. And one of the reasons why we still talk about Tycho, because as you see, like, you probably never heard of a Tycho or Tycho-centric model, because what Tycho did is he was a true scientist, despite the fact that the scientific method didn't exist at the time. He was a true scientist in the fact of this, that he believed in a particular type of model, but he just collected data and let the data determine what was true. So this is what Tycho believed. He believed that this is very different than what you see with the other models here. He believed that you have the Earth over here, right? And the moon goes around the Earth, and the sun goes around the Earth, and all of the other planets, and see these are in circular motions, all of the other planets go in a circular orbit around the sun. And I want to point out this right here, these fixed stars, because this is what is actually going to convince him that there's a problem with the geocentric or potentially heliocentric model, why he kind of was looking at something sort of in between. He had discovered, essentially, motion parallax, that movement is relative to where you are. So Tycho recorded observations with the naked eye every single day, meticulously recorded these observations, and he started to notice that some things in the sky never seemed to move at all, and other things did. And so there was a relative motion issue, and so he had to consider he was starting to consider what might be moving versus what might be staying still. So if something so far away that it appears to be staying still, or does something appear to be staying still because of the relative motion of other objects around it. So he discovered this motion parallax. The best way I can describe it for you, if you're sitting in a train and you look at, like, say, the trees that are right by the train as you're driving past, they seem to be whipping right past you. And then if you look beyond the trees at houses that you see in the distance, they're moving a lot more slowly. And if you look up in the sky and you see the moon seems to follow you the whole way. That's essentially what the motion parallax is the experience of motion as being relative to other things around you. And that's going to drive him to collect his data to prove this Tycho or Tycho-centric model. And to the question as to whether or not he was accepted or rejected, it's an NA. He died before anybody could reject what he discovered. He certainly wasn't really going against the teachings of the Catholic Church, except that he was looking to the celestial bodies instead of to the Bible. So how he died, he was at a banquet and he was in the presence of the king and apparently had too much to drink. And tradition would require that guests cannot get up from the table before the king. Tycho really had to use the bathroom, apparently sat with his legs crossed, and apparently needed to go so badly that he gave himself, according to rumors, his bladder burst and he gave himself a bladder infection. He died within 11 days of the banquet. But the scandal regarding his death, which is part of the reason why his body gets exhumed, because people thought that he was poisoned because he had had an affair with the Queen of Denmark. There was also questions around whether Kepler, who I'm going to go to on the next slide, whether Kepler had poisoned him. And I'll explain why people thought that. But when they exhumed his body, they discovered that he had not actually died of poisoning at all. So to be clear, he died from pee, not poison. He died from a ruptured bladder. Okay, so Kepler, let's first start with his connection to Tycho or Tycho Brahe. First is that Tycho was recording observations and was meticulous in his recordings of celestial movements, but he didn't have the mathematical know-how to make it all come together. So he hired Kepler to do just that. What's interesting is that Kepler will use Tycho's work and discover that his data does not support his hypothesis that remember, Tycho was supporting this sort of mixed geocentric heliocentric model, but he didn't interfere with the data. And Kepler, when he ran the math on the data, he discovered that it was in fact a heliocentric model. It wasn't the only thing he discovered from using Tycho's data. And I won't get into this too much, and you probably have done some of this in earth science, and if you go on to physics, you'll probably do more of it there. But he discovered the heliocentric model, this sun at the center of the universe, but he also discovered that it doesn't move in a circular pattern, that it actually forms an elliptical orbit. So if you look here, and this is just comparing Aristotle's early view of planetary motion, which would have been geocentric, to Kepler's elliptical orbits, what you'll have is, if you take like the sun right here, he saw the sun as one point. And the best way I can really describe this is if you were to take a nail and put it in like a board, right? Or put it in the wall, just put a nail in the wall and tie a piece of string in a, just not a piece of string so you can move it in a circle. So you fix that nail on the board, and then you take that string and you hang it on the nail, and then you pull the string around like that. You're going to get a perfect circle, right? But if you have two nails that you put in the wall, and then you put that same one string and you try to like pull like a pencil to draw around it, it will no longer be circular. It's going to form an ellipse. And so that's what Kepler discovered, was that there are two focal points. You have the sun at one focal point and an unknown at the other. And this just gets more and more complicated because the math, we haven't talked about calculus yet because it wasn't a thing So the proof that Kepler put this stuff through is insane. It's incredible. I would call it nothing less than genius. But why he was accused potentially of being one of the people suspected of poisoning Tycho Brahe, it was because when Tycho died after that banquet, Kepler, in the confusion, was afraid that he wouldn't get to work with the data that Tycho had hired him to work with. And so in the confusion, he went in and, shall we say, misappropriated Tycho's research. It's understood that that data that Tycho had collected would have gone to Tycho's children. And Kepler didn't want that to happen. He wanted to make sure that he had access to the data, and so he took it. And did a lot with it, actually. It actually disproved Tycho Brahe's initial thoughts there. But it put Kepler as a suspect, but in terms of motivation, I'm not really sure that Kepler would have had any other motivation, because Tycho was not getting in the way of Kepler's ability to get his job done there. And Tycho was paying Kepler. And as to the question of whether or not his ideas were accepted or rejected, they were, considering the time period, initially rejected and then later accepted. And let me remind you, when I'm talking about ideas being accepted or rejected, I mean most people are going to not even know about them at the time. They're speaking to just a few people. And I'm not talking necessarily about the scientists of the day. I'm talking about the political institution or the Roman Catholic Church. Protestant denominations as well. And then we have Galileo, who is also going to be proving a heliocentric model, but he is not doing it with the naked eye. He is doing it with a telescope. He also, in this, discovers the moons of Jupiter. And he discovers that it was the moon that causes the tides. So Galileo used his observations to build upon the work of Copernicus and on Tycho Brahe and Kepler, build on their theories about the heliocentric model of the universe, and Kepler specifically, his theories about the elliptical orbits. Unfortunately for Galileo, his discoveries were brought to the Catholic Church, and he was convicted as a heretic. Remember, the Inquisition was in place at this time, and they could put you in all kinds of sleep-deprived, hungry, question you, try to trip you up in your questions, try to get you to admit to something. They could torture you and even kill you if found guilty, excommunicate you, what have you. And he was convicted and found as a heretic, and he was forced to recant. And so publicly he did recant. And so obviously you can guess, when it comes to the political state that Galileo was living in, his ideas were rejected and he was tried by the Inquisition as a heretic and found guilty. I personally would mark Francis Bacon as probably the biggest turning point in the scientific revolution. In my view, and I'm editorializing, he might have had probably the biggest impact on the field of science. And I'll explain why I think this anyway. Because you saw a bit of the scientific method come out with philosophy in ancient Greece. But the way Francis Bacon is going to set up the scientific method is going to be based on experimentation and observation. So we're looking for things to be empirical, observable, testable. So you've probably learned about this in all of your science classes at the high school, this scientific method. Truth comes after investigation. Experimentation and observation are what lead to understanding. So you ask a question, you do your background research, construct a hypothesis, test your hypothesis by doing an experiment, analyze your data, draw a conclusion, report your results. Was your hypothesis correct? And kind of keep going back and questioning it. So he was saying, let the data drive. Now, why I say that Francis Bacon, so you're like, all right, scientific method, you take it for granted, but why this is such a big deal. This is the point where science clearly and cleanly becomes a different discipline. Because if you think all throughout ancient history, even pre-civilization, one of the things that people were always trying to do was understand their world, explain nature, how things work, why things are the way they are. The questions are always the same. These are the questions of human nature. And there are various disciplines that take this on. So in religion, which obviously comes before philosophy and science, in religion, you try to answer these questions through faith. You try to answer them through Holy Scripture, whatever it is, the Bible, the Quran, whatever. You answer those questions through faith. In philosophy, you answer it through questioning and reasoning. And in science, you'll see that questioning spirit. But when Francis Bacon does his bit with the scientific method, all of a sudden you're like, oh, wait a second. Like, now we're saying that the tools of science are also different from the tools of philosophy. Philosophers are using reason to answer why things are the way they are. Scientists must use an empirical and observable data. So personally, I think it was the scientific method right here with Francis Bacon that is going to be the biggest turning point in scientific history. So the other interesting thing about Bacon is that he was very politically connected. So he wasn't just a scientist, he was also the Lord Chancellor under King James. He was very politically connected. But he did lose favor with the government, with Parliament, and he was ultimately charged with 23 separate counts of corruption. It was pretty complicated, and it's likely he was the fall guy for a number of things. But because of his political connections, his ideas were accepted in his lifetime, so he got to enjoy the fact that people accepted it, that he didn't have to hide what he was studying. As to his death, it might be interesting to you that many people believed that it was a food-related injury that Francis Bacon died from. He was using snow as a food preserver, and shortly after doing so, he contracted a fatal case of pneumonia. Some people believe it was the food poisoning that caused the pneumonia, or they could have just coincidentally been like food poisoning and pneumonia. You'll notice here that I see the scientific method again, but I am not pointing to Rene Descartes and saying that he was a big turning point. He did use the scientific method, but he didn't make it necessarily all empirically based. So he put a lot of emphasis on human reasoning. So he had a big contribution really to the area of math and analytic geometry, and gave us what you guys are probably very familiar with and may not recognize the term Cartesian coordinates. You can also thank Descartes for being the reason that you have to check your work in math, because he was meticulous. His idea was you solve any problem by breaking it down into smaller components and then constantly check and recheck as you go along to make sure you got it right. So now I think you should recognize Cartesian coordinates. When you're plotting on X and Y, you're using Cartesian coordinates. So when it comes to the question of whether or not he was accepted or rejected, Rene Descartes was rejected. And he was in many ways okay with that. Knowing that he was going against the church, he would actually take his work, his findings, and send it to theologians to have them criticize him, and then he would publish their critiques. And since Descartes was Roman Catholic in a Protestant nation and not accepted by the Roman Catholic Church either because of some of his studies, he ended up being buried in a graveyard for unbaptized infants. And I'm going to put Isaac Newton up there with Francis Bacon in terms of a turning point. Francis Bacon changes the field of science and makes it about what's empirical and observable. Isaac Newton takes everything that all of these other people have done and put it all together. He discovered the missing piece. He discovered gravity. And I know a lot of people question about the apple. Did the apple fall and hit him on the head? Was there an apple? I don't actually think it matters. What matters is the point. There was the apple falling on him and what was beyond the apple. Newton was the first person to unite this earthly or terrestrial observations with celestial ones. And he did it with understanding the force of gravity and the laws of motion. But that gravity, he's going to say, all right, Kepler's laws, they work because of gravity. It is gravity that keeps us in orbit. So essentially, that gravity is so important. It is what makes Kepler's law. It's the final piece of Kepler's law. And Isaac Newton, brought calculus to this as well, which you have to remember that Kepler didn't have that at his disposal. So his proofs were just these astronomical things. Isaac Newton, with his calculus, was able to prove a lot more. He adds the gravity, he has calculus. I'm sure you've heard about his laws of motion. An object at rest will remain at rest unless acted upon by an outside force. An object in motion will remain in motion unless acted on by an external force. And I think when we're talking about Newton, it's easy to forget that he did a substantial amount of work in the ocular world. So when he was using prisms to refract light, he broke it into, and actually he's the reason why we have the 7 colors of the rainbow, because you know that there are way more, infinitely more colors that you can break that down into. But he thought 7 would match the 7-note scale. As you get to the 8th note, you're back to, your C major scale. By the time you hit the 8th note, you're back on C. So he liked there to be harmony in these sorts of things. As to whether or not his ideas were accepted or rejected, his ideas were primarily accepted, which is really good for Newton since he was actually not known to take criticism all that well. When you take physics, or if you take physics and you learn about Robert Hooke and Hooke's law with springs, you may also learn that Newton did an enormous amount of damage to Hooke's career because Hooke accused Newton of not crediting him with something that was his. Essentially, Newton wrote this book, The Principia, and I'm hoping I'm saying that right. But in this book, he's describing gravity. But before he published this book, he had been in a correspondence with Robert Hooke over the ideas of gravitation. I mean, on top of all of this, like I said, Newton did not do well with criticism. In fact, many people would say that Newton really unnecessarily ruined Hooke's career over this. Newton also really wasn't much of a people person. He didn't have friends, really. He didn't do well with them. In fact, apparently he had a roommate that he did rather well with because the roommate understood that they would not be hanging out, they would not be socializing. He just let Newton do his stuff and the two of them would be fine. And there, and I want to let you know that obviously, well, this isn't a science lecture and I'm only giving you some of the very basics here, but I want you to know the people that are important. And they are in the reason they are because one came before the other and built on the other, or they were contemporaries, and so it was really kind of whose work got taken to first. The whole point of telling you the stories and the gossiping about them is it will help to make them more memorable for you.